right, cool. All right, folks. Thank you very much for your patience. All right, so we want to dig back into some of the algebra today. We have a couple of things to tackle, but I do want to get to the quadratics. That might happen next week, though, so we'll see how that goes. So you could check those comments there. Pop out chat. Oh, thanks for the likes, guys. I appreciate it. All right, put that there. Okay, cool. All right, so I think we're good to go. All right, ladies, gentlemen, let's take a start, right? So I just have a couple of questions here to kind of run through it, y'all. 1, 2, 3, 4, 5. I'd prefer you have it as opposed to writing it down. So just give me a set. Let me print it for you. Right. So we're just going to finish up a couple of the inequalities questions. This one was from Jan 2022, as the date implies there. It was a bit unique in that it was one of the very few questions where they give you the algebraic expression between two numbers, right? So it's greater. It says 2 minus 4x over 3 is, in the first instance, sorry, 1 second. We on the board, ladies? We on the board, right? Right? Shh. You know what, guys? If you want, the inside room is actually free. You could put on the lights and the AC, and you could go inside there. That might be a little better noise-wise, no? Cool. Right. Pool K? Shanika, I'm not sure what pool K means, but all right. They're still loud on the inside of the next room. So, okay, let's see if that helps a little. Connected to new network. I am? Why am I connected to new network? Who did that? Okay, I don't know. Right. So, like I was saying, this is one of the few questions that they brought with inequalities. See, I'm on the board. Question right in front of you. Right. So, like I was saying, this is one of the very few. So, if you look at all of the others we had so far, it was kind of more like a regular looking equation like thing. You had an expression equal, less than equal to something, or you had one expression less than the next one, right? This one here too, as you could see, kind of in the same vein, right? This one here, two expressions, one on either side, right? So this one was the only one we saw so far where we had what you call it, the expression between two integer values, and they're asking here determine all the integer values of x which satisfy the inequality that. So what is an integer? An integer is a whole number. So it's a number that is not a fraction, not a decimal, there's no piece, right? Sorry, yeah. Okay, so how we solve this? One way you could go about solving it is you can pull it apart. What I mean by that is you could work I guess you go the left half initially, and then you could go back and work the right half. Each one will give you a separate solution, which we will combine for a final solution. So let's pull it out, right? So in the first instance, let's pull minus 1 less than 2 minus 4x all over 3. Okay, so here we want to solve for x. So right now, x is being multiplied by 4. That product is being subtracted from 2, and then we're dividing by 3, right? So generally speaking, like I said, we have a fraction. If you want to kind of get rid of the fraction, we have to remove the denominator. How do we remove a denominator? What operation do we use? Multiplication, because we understand that the fraction is a numerator being divided by a denominator. So to remove the denominator, we will do the opposite operation. Opposite of division being multiplication. So we multiply by 3. Right, so when you multiply by 3 on this side, it'll cancel with your denominator, leaving us with just the numerator, 2 minus 4x. And of course, whatever happens on one side of an equation must happen on the next side. So minus 1 by 3 will give us minus 3. Okay, now from here, we have a couple of different paths we can take. We can move across the 2, right? Which most people end up doing. But let me show you how they do it wrong, right? They'll look at this and they'll say, well, the 2 is connected to the 4x via subtraction, which looks like it's a correct statement. And they say, okay, so to remove the 2, I have to add it. So they'll do this, which is wrong. Let me tell you why, right? It's wrong because if you were to remove this 2 from the right-hand side, you are seeing a subtraction connecting it to the 4x. But are we subtracting the 2 or are we subtracting the 4x? The 4x. The 4x is the negative 2, right? And then if you are moving this then, what I was supposed to say is that what is the understood sign or operation in front of that? If no sign is explicit, we understand as being regularly positive or being added, right? So if you were to move something attached by addition, you'd have to use the opposite operation, which is subtraction. So this should actually be minus. And if you do that, right, that would be correct. But then if you do move that 2, right, the minus stays in front of the 4 because we are subtracting the 4x, all right? So then this would now be the more correct statement, all right? So another way that you could do this, right, again, if that minus sign gives trouble, which it does for a lot of students, is you could just rearrange this side to say minus 4x plus 2, right? See, the minus stayed in front of the 4x, and the 2 initially had no sign explicit, but of course, when you put it behind, you put that it's being added because it is a positive term, all right? So now, if you want to, you could move the 2. We could see the 2 is being added. To remove something attached by addition, we use the opposite operation, which is subtraction. So when you subtract 2 from the right-hand side, it'll cancel, leaving us with just what? The minus 4x, sorry. And of course, whatever happens on one side of an equation must also happen on the other side. So you'd have minus 2 here. And then we have minus 3 minus 2. So when they both have the same sign, what do? We add them we add them together and put back the sign. So minus 3 minus 2 will just give us minus 5. If you want to think about it on a number line, right? So you have minus 1, minus 2, minus 3, minus 4, minus. So if you have minus 3 and you have the minus 2, when you're subtracting, which way are we going? Left or right? We're going to the left. And if you're subtracting 2, you're going to the left 2 spaces. So minus 5 would be the answer there. All right? Clear for you, all right? Just in the middle distance. You have some trauma that you're working through. Math trauma. All right. Okay. And the last thing to remove is the minus 4x. Now, yes, the 4 has a minus sign in front of it, but how is that minus 4 attached to the x? What operation? Multiplication, right? And how do we remove something attached by multiplication? We use the opposite operation, which is division. So we'll actually divide by minus 4, right? Now, let me show you, first of all, the mistake most people make. They'll do this. Minus 5 over plain old 4. And I'll ask them, why did you do that? And they say, well, sir or miss in school say when something go across the sign, the equal sign or inequality sign, it'll change the sign. And you see, in the earlies, when you're only moving stuff across as either being added or subtracted, that could work. But when you have division and multiplication, that shortcut creates a problem because you think anything that goes across has to change sign. That's not so. All right. So that's why you'll hardly hear me talk about when you move something across, you change the sign. I will say it from time to time, but you didn't hear me say that's not the way I like to explain it, right? Anyhow, so the minus 4 is attached to the x by multiplication. To remove it, you have to use the opposite operation, which is division. Sorry. Right. So, hey, Javi. Hey, Javi, how you doing? Good afternoon. Good to see you on. All right, we're doing some more algebra today. We're trying to round off a couple things to get to quadratics, but we have a couple other things to work through, boy. Direct proportion and seeing some simultaneous equations popping up there, so we'll see how it goes. Okay. All right. We're just working through this one inequality question. It was the most interesting one because it had it had the expression, the algebraic expression between two values. So we said what we do is we work each side separately, right? So I just walking them through the first side, and they're going to try the second side. All right. Right. So here now we're going to divide by -4. Now this is the trick that you have to pay attention to when you're doing inequalities. If you ever multiply or divide by a negative term, the sign has to flip horizontally. Right. So of course, if you divide this by -4, it'll cancel the coefficient, leaving us with the x. And now you could write. So of course, on this side now, when you divide a minus by a minus, you get a plus. So you could end up writing this as simply x less than 5/4. All right. Now, the other way you could have worked this is you could have said initially, all right, -3 less than 2 minus 4x, right? That's right after you multiply by 3, right? What we could have done here, Minnie, what we trying? Right, so like I was saying, the way I don't like to explain this is you could carry across the -4x and change it to positive. So in other words, you could add 4x to both sides, right? Then the -3, when you're moving the minus, it becomes a what? It becomes a plus. In other words, you add it to both sides. What's 2 plus 3? 5. And then to move the 4, you have to divide, not so? And we end up with the same answer as across here, right? We took a slightly different way to do it. Which one, the green side? Right, so yes, I agree. The green side is easier, right? So the basic rule I would tell you that I use for myself is if I'm trying to solve for an item and it initially has a negative coefficient or it's being subtracted, I will move it across to the next side to make it positive. And then from there, I could just move everything else, all right? Now, of course, things get complicated if it's in a bracket or if it has a square root sign in front of it or if any bracket is raised to a power, all kind of stuff, right? So you just have to take your time and go through it piece by piece. Oh, hey, Jerry, thanks very much for the ice cream. Appreciate it, man. Hey, looks like welcome back, boy. What vibes? Right. But yeah, I would say the working in the green to me is the easier one to do. All right. Now, with that set of stuff there, what I would like you to try for me is to do this side of it, and then we will talk about the final answer, right? So, no, remember it was between -1 on the left and +5 on the right. So we just took the one on the left-hand side. I showed you two different ways to work it. So now what I would like you to try is I'd like you to try, sorry, 1 second. I'd like you to try the blue. Solve for x, right? So the first thing you're going to do is multiply by the denominator throughout. You multiply by 3, get rid of the denominator, and then shift around the stuff on the top. Right? And what you could do, you can move across, just like I moved the -4x first to make it positive. You could do that here as well. Well, after you multiply by the denominator. Okay, so I'll give you a couple minutes to sort it out. If you have any questions, please feel free to ask. It's not a problem. Sorry. Cool. Sorry, who's it? Signed by B. So what I see in here? You're seeing some maths, some inequalities. Oh, wait, my head cut off. We're talking about the three images. No, colorful throw. Or the fuzzy hat. By B. Sorry. All right, let's get a couple of steps going. Nikki, I'm echoing. Okay, I wonder how to solve that problem. One sec, I have an idea. Right. Nikki, let me know if I still echoing up these and that. The room have some kind of ambience. It have a little bit of reverb you will hear, especially when I projected my voice. But generally speaking, it shouldn't really have much of an echo. But yeah, let me know, please and thanks if it's still echoing. Siobhan, right, okay, folks. All right, cool. All right, okay, so Q&A, what's the first step you're going to take here? Less than? How you get 2? All right, hold on. So we started with this one, right? 2 minus 4x all over 3 less than 5, right? That's what you have. That's the starting point. All right, cool. So you said 2 minus 4x less than 2. To get 2, you have to do 5 minus 3. But tell me something. How is the 3 attached on this side? It's the denominator of a fraction. And the understood operation is division. So to move something attached by division, what we're going to use? Multiplication. So you multiply by 3 first. When they multiply by 3 on this side, it'll cancel your denominator, leaving us with just the numerator. And when they multiply 5 by 3, you get 15. All right? So when you're reading this left to right, it'll say 2 minus 4x is less than 15. Right? So that's how you'll say that side. If it was the next way, you'll say 2 minus 4x is greater than 15. Okay? Sorry. Should I drink tea instead? Okay. All right. Okay. So Zian, from here now, what would you do in order to facilitate solving for x? What's the next step you would take here? Which one do you want to move? The 2 or the minus 4x? 2. All right, cool. So the 2 on this side, is the 2 on this side positive or negative? Positive. So how do you remove something that is positive? Add or subtract it? Subtract it. Right. So we'd subtract 2 from both sides. So on this side, if you subtract 2, it'll cancel this 2, leaving us with just the minus 4x. As less than, of course, and of course, what happens on one side happens on the next side. So 15 minus 2 will, of course, give us 13. All right. And Hanifa, what was the last thing we would do to get x by itself? Was the only thing left attached to the x there? Minus 4. How is it attached? What operation attaches the minus 4 to the x? Right. So if you just have a number next to the letter, then multiplication is understood, right? So how do we remove something attached by multiplication? We use the opposite operation, which is division. That's correct. So divide by minus 4. So if you want to see it explicitly, we'll divide both items by minus 4. And again, when you're dividing with inequalities and you divide by a negative, yes, Nikki, very good. Hey, Jada, thanks very much. You flip the sign horizontally, right? So, of course, on the left-hand side, the minus 4 cancel with the minus 4. Sorry, I didn't mean to put an x there, my bad. Leaving us with x, and this is greater than, and of course, this will just become minus 13 over 4. Right? Now, if you wanted to see it a slightly different way, right? Right. Because if you had a positive and you divide it by a negative, right? So when you divide a positive by a negative, the overall answer will be negative. So the whole fraction just becomes negative. But whether the numerator alone is negative, right? If you leave it as 13 over minus 4, it's the same thing. It means the same thing, right? If you put minus 13 over 4 or 13 over minus 4 or minus in front of 13 over 4, they all mean the same thing. Right. Well, that wouldn't be correct. I could agree with that. Okay, but that's okay. Right? Mistakes are part of the process. That's how we learn. Okay, right. So again, another way you could have approached this, right, is similar to the one in the green that I showed you all that you all kind of preferred, right? So the first thing I would do, yes, is multiply by 3 on both sides of the equation. 5 by 3, of course, is 15. And if I multiply by 3 on this side, it'll cancel my denominator, right? Now, what I would do here is I would actually move the minus 4. So if the 4x is being subtracted on the left side, how do I move it to the next side? I'm multiplied by the denominator. Sorry, I don't want to erase. Right? Right. So if I want to move the minus 4, what I do? I'd have to, what operation would I use? Addition, right? So when I add 4x to both sides now, right? If I added 4x on this side, it'll cancel with the minus 4x, leaving me with 2. And of course, whatever happens on one side of an equation must happen on the next side. Right, so now you could always even rewrite this as 4x plus 15 because as we know, addition is commutative. 2 plus 3 is the same as 3 plus 2. So 15 plus 4x is the same as 4x plus 15. Now, to get x by itself, what's the next thing I'm going to move here? Julie? Here. I want to get x by itself. What's the next thing I'm going to move? What's the easier thing to move? Before the 15. Right, how is it attached on this side? How do I remove something attached by addition? Correct, so I'm going to subtract 15 from both sides of the equation. When I subtract it from the right-hand side, it'll cancel, leaving me with just the 4x. And of course, whatever happens on one side of an equation must happen on the other side, 2 minus 15. Right, so now 2 minus 15 is minus 13. You had 2 positives, 15 negatives. Right, so every positive will cancel with one negative. So if you only have 2 positives to cancel, you're losing 2 negatives. And if you have 15 and you lose 2, how many you have left? 13. All right. And the last thing that we have to move is the 4. Right. So, for how we move the 4? How is the 4 attached to the x? And to remove it, I have to use the opposite operation, which is division. Very good. So when I divide by 4, it'll cancel with the numerator. And of course, whatever happens on one side of the equation must also happen on the other side. Sorry. And yeah, sorry, you also could have written this as, yeah. You could write it like this. X is greater than minus 1304. Now, after all that, we're still not done, eh? Right. We're not done. I don't know, I didn't put the marks. Yeah, I didn't put the marks. If you want to see though, give me a second. This is Jan 2022. Jan 2022. 1 second, eh? Jan, no, that's the bearings. I don't want that. Jan 2022. Yeah. 3. Right. I do extra steps in the working, so anybody who doesn't understand will see the working. So when you do it now, you don't have to show every single step. Right? So basically what would happen is you get 1 mark for solving the left side, 1 mark for the right side, and then a mark for the final answer. Because what's the question asking? Determine all integer values of x which satisfy the inequality. So now check this, right? 1 second. I need a different color. Right, cool. Right, so currently I have x is less than 5 quarters, but more than minus 13 quarters, right? Now when I bring it here, I have x is less than 5 quarters, but x is greater than minus 13 quarters. Now, what do we start off by asking? What is an, it says determine all the integer values. What is an integer again? A whole number. Do we have whole number values there? No, they're both what? Fractions. Okay, let's make them into mixed numbers. That way it might be a bit easier to determine the whole numbers that would work, right? So minus 13 over 4. 4 goes into 13 how many times? Without going over? 3 times, right? Remainder 1. And then 5 over 4. 4 goes into 5. 1 time. We're not going over, right? So this is like minus 3.25 less than x less than 1.25. So check it. Let's consider this side first. So x is less than 1 1/4, right? So if you're talking about whole numbers, right? So let's put 1 1/4 there, right? What whole numbers are on either side of 1 1/4? 1 and 2, right? But if we have to go less than 1 1/4, is 2 less than 1 1/4? No, it's greater than. It's bigger than, right? So the nearest integer value, the nearest whole number value that satisfies x being less than 1 1/4 is what? 1. Now, for this one, x has to be greater than minus 3.25. Now, greater than means you're going this way. What whole numbers lie on either side of minus 3.25? So minus 4 and minus 3. It lies between minus 4 and minus 3. Which one, right? So if x is greater than minus 3.25, right? Which integer value there would correct, which is the minus 3, right? So the whole numbers, right? So the integer values that satisfy this, right? So the answer is minus 3, minus 2, minus 1, 0, and 1. Because what did they ask for? All of the integer values that satisfy this inequality, right? So if the smallest one is minus 3 and the biggest one is positive 1, you have to take all of the whole number values between minus 3 and 1 inclusive, right? So that's why I wanted to make sure and do this question, because it was the most different out of all of the inequality questions, right? And it didn't come too long ago. It came in 2022. That's 3 years ago, right? You know, that was the year before yours. All right, gentlemen on Google Meet, D'Angelo, Donovan, Javi, and Liam. Just give me a quick Genie chat if you guys are good with this stuff on the board, please add that. If you have any questions, please feel free to ask. If you need me to re-explain, give me an R. Well, okay, right, well, I get all of them. All right, Diane and Q now. You have any questions? I know there's plenty of stuff up on the board there, but you understand what they asked for, the integer values, and how I determined it from after I got to here? Okay, so let me assume you get through all that, right? And again, you would need to do all. You either have to do either the pink or the green, right? Because they both solve the same thing, right? And you can do either the blue or the orange because they both give the same answer, right? So let me see you get down to here now, right? That x is greater than minus 3 1/4, but less than 1 1/4. And you remember that the question say, hey, I want all of the integer values. Integers are what? Whole numbers, right? So let's put a bigger number line down here, right? So 0, 1, 2, 3. Minus 1, minus 2, minus 3, minus 4. Right. Now, where are these values here on the number line? So 1 1/4 would be somewhere here, right? 1.25. 3 1/4 is minus 3 1/4 is somewhere, minus 3.25, right? So the first thing we are saying is that the value of x must be greater than minus 3 1/4, right? The greater than goes this way, right? Minus 4 is not greater than minus 3, it's actually less. It's more negative, which means you're taking away more, which is less than minus 3. Think about it. If you pay me $4 or $3, which one? Okay, if you have $10, $5, and you pay me 4, how much you have? $1. If you pay me 2, how much? Sorry, if you pay me 3, how much you have? 25, yeah. 2, right. So if you pay me 4, that's minus 4. You have less left, right? So that's more negative, which means you have a lower number. If you pay me minus 3, that's actually a greater number because you're left with more. You're left with $2 as opposed to 1, right? So, the first whole number value greater than minus 3.25 is minus 3. You okay with that? All right. And now on the other side, it needs to be less than 1.25. And the first integer value less than 1.25 is 1, right? So the answer here, right, that they want all the whole numbers that satisfy the inequality in the box here, right? So all the whole numbers. So if you start from minus 3, you go to minus 2, minus 1, 0, and then 1. So those are all the possible integer values that satisfy the inequality, right? So I know, yeah, like I said, I know there's a lot to kind of bite off and chew. But I wanted to make sure and do that particular one before we went on to anything else. Because, like I said, it was very different and it was recent. All right. Okay, cool. All right. Now, We do some simultaneous over proportion, boy. All right, let's do some proportionality questions, right? Some people call this variation. That's perfectly fine as well. Right? So I'll zoom in here. So more people online at home could see a little more closely. Right, May 2016. So you can take a read. So the table below shows corresponding values of the variables x and y, where y varies directly as x, right? Oh, I don't want a pink, I wanted the yellow. Right. Y varies directly as x. Okay. Right. So variation or proportionality tends to be a bit of a sore point for some people, right? So I'm going to go through this first question as an example, right? If anybody at home knows what to do, you could go ahead, send me a pick of your work, please, and thanks. I'm going to know how you're going, right? Okay. So that statement in yellow, right? To translate it into a mathematical statement, we use the following. So y varies directly as x, right? So y, hold on, do I want this? Okay. So we shorten this whole phrase here with a symbol. And that symbol will look like an infinity sign with one side of Jolie, be on the screen there. I have a basket. I can put the phones there, you know? Oh, okay, cool. All right. If I don't hold it, I'll have somebody else hold it. Mommy or daddy. Because I had to get them a call and say things distracting only. And we 20 days out from the POA exam, which means we are 24 days out from the maths exam. 24, 21, 22, 22. 22 days. Right. Right. So it looks like this. So like I said, it's an open-ended infinity sign. I can't draw it that well, but maybe you could do better than me, right? That gonna work. No, I lie, that wouldn't work. I hate that. Right. Aha, that's the best, right? So this line here is what how we would write in with a mathematical symbol the above statement, right? So y varies directly as x. And what that means is that as x increases, y increases, right? If x goes up, y goes up. And but vice versa, if x were to go down, y would also go down. And the understanding, therefore, is y is therefore equal to some constant k multiplied by x. Now, k is just an arbitrary letter. You could use n, you could use t, you could use c for constant, you could use p for proportionality. It don't matter, right? Just don't use a letter that's already in use. Don't use back x, don't use back y, right? If they give you p and t, don't use back p, don't use back t, right? Usually k is a safe one. If they use k, use something else, all right? So, right, so if y varies directly as x, this is the statement, the mathematical statement that is equivalent to that English statement. And then we go here. It means that y is equal to some multiple of x. Now, that k could be a whole number. It could be a fraction. It could be positive. It can be negative, right? Because varies directly as means that it's as one increases, the other increases as well, right? Okay. Now, what we want to do is you want to solve for the value. If you give me a few minutes when I finish this, I'll try it, right? Functions, you say? Yeah. All right, cool. Okay, right. So here, they give us a table above here, and we have some values. Sorry, we have some values, right? Of x and y. Now we have a couple of unknowns. We have the u and we have the t. We don't know what those are. We're looking for them. In order to solve for those things, we need at least one corresponding pair of both of the numbers. Do we have that? Do we have any of those cells giving us x and y? This one here, right? Right. So we use that to solve for the value of k, right? So from the information above, right, we know that sorry, 3, which is y, is equal to some constant k multiplied by x, which is 6. So we're just using back the values of 3 and 6 inside the statement down there. Now, if 3 is equal to k multiplied by 6, which is the same as 6 by k, how do we solve for the value of k? You have to remove the 6. How is the 6 attached? By multiplication. How do you remove it? You need division. So we divide by 6. So we divide both sides by 6. Right? This will cancel, leaving us with just k. Right? So normally this would be what they show you. Right? And what's 3 divided by 6? That's a half, right? 1 over 2. How do I get the 3? What's that? Oh, okay. Right. So 3 goes into 3 one time, and 3 goes into 6 two times, right? So that's how we get the half. Right? So now we could use this value of a half inside of our statement here. So no longer will we have to write y is equal to k by x, right? We could take these two things to then write that y is therefore equal to a half by x, or you could say x over 2. All right? Now that we've solved for the value of k, right, and we have the actual thing there, right? So let me actually write, right? So y is equal to either a half by x. What do you prefer, a half x or x over 2? A half x? Okay, cool. All right, so now let's see if we could find for the value of u, right? So with u, is u a y value or an x value? U is a y value, right? What's the corresponding x value to that? 10. So we could put that u is equal to a half of 10. And what's a half of 10? 10 divided by 2 is 5. Right. Hey, so is it possible to do some linear programming for it? I actually did linear programming early this year. If you go on my YouTube channel, you can search for linear programming, you should find it. Right? But right now we're doing algebra. Right? But yeah, linear programming is there on my channel. It's alive. So you gotta kind of bulge through to find the actual parts. All right, now the next piece we had to find, so that's this piece here. And the last piece we had to find is t. Now, is t an x or a y value? T is an x value. Do we have the corresponding y value? 9, right? So from that perspective now, if you again go with y is equal to a half by x, we have that 9 is equal to a half by t by u. So is t? Yeah, it's t. A half by t. Right? So to solve for t, you have to move the half. How is the half attached to the t? Multiplication. How do we remove something attached by multiplication? Division. So you'll divide by a half on both sides, right? Dividing by a half is the same as doing what? Multiplying by 2, right? So basically what will happen is you'll get 18 is equal to t, right? Say again, sorry? Right, because u was the y value, which went on this side, right? T was the x value, which went on this side. Yeah? All right. Right, so if you divide by half, right? So again, if you want to see the whole divide by a half, right? So we could do 9 divided by a half. Because of course, if you divide by a half on this side, it'll cancel with the half, giving us just t. Here now, we're dividing by a fraction. What's the protocol for dividing by a fraction? You change divide to multiply and you invert the divisor. Right? And 9 by 2 is 18. So 18 will be equal to t. Okay. So that's your example, May 2016 example for variation. All right. So D'Angelo, Donovan, Javi, and Liam, if you guys are good with that example, just kindly give me a quick Genie chat. If you need me to re-explain anything, that's not a problem. Just let me know. Make fit the screen. Okay. Like that. Disrupt 101. Cool. All right, so let me put the next one to print for you guys, right? Or you need more time to copy anything now? Good? All right, cool. Hold on. All right, we'll just go in order. How about that? Good? All right, good. Lovely. All right, so it's printing for those in class. Those at home, you could just, like I said, you could take a screenshot. You could, if you want to send pics in the chat, I could do that too, right? But it's going to stay on the screen for the most part, right? Just give me like 15, 20 seconds to give all the printouts here. Hold on, let me just check something real quick. All right. Cool. All right. Yeah, well, slightly more. Just open up some more energy. Right. So what topic is this? Also, I can barely hear you. There's like this echo. Let me check out this thing. Yeah, because people complained about the echo before, but yeah, because when I started up TikTok this morning, I had to re-add all my accessories. Right, just now. I'm going here. Um, just now. So I gotta mute that because if not, all right, cool. Can I not full screen this thing? Yeah. So what's going on with the echo? Yeah, I hear it now. That's not usual. Even after yesterday when I had to download a recorder and there was no echo. So why is there an echo? Right, give me 1 sec. Settings. Oh, I think I know why. Right. Advanced audio settings. Let's speaker. If that helps. Yeah, maybe now. Oh, so weird. Audio mixer. All right, let me see this. Primary microphone. Oh, that is why. Yeah. Okay. Cool. How about now? Yep. There you go. That's exactly what happened. I had two microphones on the same device. Ah. Yeah, guys. Sorry about that. Note to self. Those replays mightn't be very good. Anyhow. All right. So sorry to answer the question. This is proportionality or variance. Way better. Yeah, man. Thanks, no. Yeah, man. All right. Cool. Okay, I did. I am so sorry. And it have our next building of POA class to ask for documents on Monday. And I said I sent it Monday. What's today? Wednesday. I sent it yes or no. And she messaged yesterday morning. And I was very apologetic. I didn't send it yet. So I'm sorry about that. But things just fast and furious. All right. But you all started? Okay, great. Didn't know how to tell her to start. Very good, very good. I can read my book. If you're on autopilot, these things. take a read here. Right, the force F applied to an object is directly proportional to the extension produced by that object. Okay. All right. So what would be the mathematical? Julie, all right. I can start and fall on like a dog die. All right. Eat a biscuit now. See that help. Right. Yeah, Mekai, I'll try and see if I could organize a little something for you. I don't want to leave your hand. Sorry about that. Okay, where was I? Right. So represent this information as an equation in terms of F, E, and an appropriate constant K. Okay. So as we saw before, if F, right, the force applied to an object is directly proportional to the extension E, it means that force is direct. Why can I not draw this thing like a regular? Oh my god. Right, that will work. Force is proportional to extension, which then will give rise to force is equal to some constant K, then multiplied by ED extension. So you could leave it as that, or F equal to KE. Yeah, I hear any truck passing there. You done retiring? I thought you were retiring. Right, that's the first piece. The incomplete table below shows corresponding values of F and E. Right, it says using the equation obtained or otherwise determine the value of X and Y. So they want to find X and they want to find Y. So the first thing we need to do is to find the value of K. So what we're going to do is, just like we saw in the previous page, we're going to use the pair of corresponding values to solve for K. Now the good thing is that we actually have two pairs of corresponding values. We have 8 and 0.2, and we have 60 and 1.5. So you could use either of those to solve for the value of K. All right. Oh, sorry. I was supposed to put that in a purple. My bad. All right. So let's see how that looks. Right. So if F is equal to K multiplied by E, if we do the green, if F is 8, that's equal to K multiplied by 0.2. So to solve for the value of K, what would we do with the 0.2? We would divide by 0.2 on both sides of the equation. And when we do that, we get a value of 40 for K. Uh-huh. What's that? If you use the other values, the 60 and the 1.5, so if F is equal to K by E, so F is 60, K, right, is the constant, and then you have 1.5. So to solve for the value of K, you can divide by the 1.5 on both sides of the equation, and that will give you 40. No, because you're dividing by 0.2.
No, wait.
Oh, okay. Right. So will you be doing, no, actually I'm hoping to get to some simultaneous equations in a little bit. We have like 2 more questions on this to do. But it's an algebra focus, that's what it means. Yeah. All right, guys in Google Meet, just give me a quick genie chat. Please and thanks. Khalifa, what's the story? What? Uh-huh. Okay, so you put 0.2 is equal to K by 8? That way? Okay. Right. So just to let you know, is that is what I did the first time with this question, because of when I did physics, this is actually something called Hooke's law. And I know the next way that extension is proportional to force. So I don't know why they put it this way, right? but it's wrong because this is the x value here. So sorry, no, sorry. Look, they put the x down here, right? So in this piece here, the x was on top and the y was below. In this piece, y was on top and x below. No, I agree with you. I agree, right? But that's just how it was in this question, right? The y was on top and the x was below. But you had to read the question carefully, right? Because that's what they told you. Look what they told you. It says in the first line, force is directly proportional to E, which means in the pink, F was on the left-hand side and E was on the right. Okay? All right. Thanks, fellas. Yeah, talk to me. I had same t-shirt I got last Christmas from your store self when I passed for coffee in the morning. Right? Right, so it's the same thing Khalifa did. So F is proportional to E, right? So you have F as point. Is 0.2 in the F row or the E row? And the 8 is in the F row. So this should be 8 equal to K by 0.2. You're getting 1 over 40. Is 1 over 40 equal to 40? Yeah, so, yeah. You want a fresh print or you just read? All right, okay. All right. Okay, so now that we have the value of K, we could find the value of X, right? And we could find the value of Y. So I'll give you a minute or two again if you haven't yet done it. I'm going to just check my methodologies. This morning I passed Superfarm and on the way out I happened to see a headline on our paper saying CXC to make drastic changes to exams. But it had nothing to do with all year. The first thing, the first time it could possibly happen is 2027, right? Because the 2026 syllabus already. But long story short, here what they're doing. They're doing something now called C-Tech instead of C-Sec. C-Sec still in it, but they have 3 tracks. You have an accelerated track, right, which you can do the exam faster, and they're breaking the syllabus up into 3 modules, right? This is under the dollar, right? Right. So you could pick how you want to approach it based on your needs. So, like, let's say, for example, Kiona works, right? So for Kiona, it might make more sense if she was in that timeline to do the 3 module approach. So she could study like 1/3 of the syllabus, take that exam, and pass that. And then, right, but that will only be available, I think, from next year for 2027, 2028. Nothing to do with me. I'll send you the article, right? Well, so they say. Yeah. Huh? Yeah. When I saw this one, I'm like, what's going on here? No. So they have the accelerated one where you can actually do the whole syllabus in less time. Like a 9 or 10 month something. Instead of like Form 4 and Form 5. I don't think that's it. No. Basically, what would happen is that you'd be able to sit like 3. Okay, this is my interpretation. It could be completely wrong, but that when I read it, what I understood was that they were saying, especially for people who work in or have to repeat or whatever the case is, right? You could do the syllabus in 3 parts, right? And when you pass all 3 parts, then you get your grade, right? Happy birthday. I am saying that word. All right, back up. Hope you have a good birthday. Anyhow. Yeah. Yeah, I agree. I don't know about the time frames. I'm not entirely sure, but to me, if it is that you're doing that, you had to get them. It had to be more time. I don't know. People are saying things about the January exam harder than the May exam, and then they say the reverse. I find they're about the same, but again, that's just from my perspective. Really? All right, that's interesting. All right, I want to start solving for x here, right? So x, right? Oh, sorry, I was supposed to actually write that from this now, we could say that f is equal to 40 by e. Sorry, that look like a e, look like a, right? Okay, cool. So from here now, Where's that accent from? Trinidad and Tobago. Right. So let's go to find that x. So if f is equal to 40 by e, and f is 25, and e is, well, the value is unknown. So now, if you want to solve for x, you have to move the 40. I see that confused look on your face. Well, you mix it up, do? You put 40 equal to 25x on. That's correct. You would divide by 40. That's correct, yeah. Sorry. Uh-huh. Mm-hmm. Hold on, you multiply what by the 0.025? 25 by 0.025? Yeah, I agree. Right. No. Because what you did is you mixed it up again. So you did two wrongs and then make a right. Yeah. Right. Okay, check it, right? If you put the 0.025 on this side, right? Mm-hmm. Right. Mm-hmm. This is your uh-huh. By F. But you realize that yeah, that's yeah, F 25. Right. No, but what I'm saying is that you using, hold on, your value here of k was your value of k that point, the point, right? So that's wrong because it's what you use. Right. No. Okay. Hold on. You reversed the working, so you got your value of k as 1/40, right? Which is 0.025, right? Now, what you then did was you actually did the correct kind of transposition, right? They said, okay, to solve for e, I had to multiply. Sorry, I have to divide by this thing, but you actually multiplied. Because think about it, your value for k is 1/40, the 0.025, right? You multiply that by the 25, which is a f value, right? But remember, f is equal to a multiple of e. F is equal to something multiplied by e. So to solve for e, you had to divide f by the something. You didn't. You multiply the f by the something. Your something, right? Which would actually give you the correct answer because when we divide by 40, right? Dividing by 40 is what you got as your e. So you did two wrongs and ended up getting a right. That's the problem. No, you won't, because they would see that you did two wrongs, right? So yeah, you wouldn't, if you did two wrongs and you get the right answer, you wouldn't get the mark for the answer. Okay, and the last piece here is that y, right? So y is the f. So in this case, so again, f is equal to 40 by e. So the y is the f value, and they have 40 multiplied by 3.2. So there's a straight case of multiplication. So 32 by 40 is 128. So y is equal to 128. And that is it. All right, fellas on Google Meet, if you guys good with that, give me a quick G. Please and thanks. You did the 150. You mean 1/40? Right. So once again, the correct value for k is not 1/40. It is just 40, right? So right. So yeah. So when you flip it, it will become 40. So when you, because if you divide it by 1/40, yes, you would flip, right? But once again, here we didn't need to divide. So it's like you got the wrong value, you put it in the wrong equation. So when you did it working, you end up getting the right value. Yeah, that's what I was just telling Khalifa, right? So if you get the correct answer but with incorrect input, they will not give you the mark. Yeah, but all right. Yeah. So once again, I understand your pain with this question because even I got some trouble because again, the way they phrased it is they kind of did the opposite of the physics rule, right? So they said that the force is proportional to extension. Now that is still a correct statement. Imagine this, right? You have a spring, right? The harder you pull the spring is the more it would extend, not so? Right. So that is the law. The extension is proportional to the force applied. But what they told you here is that the force is proportional to the extension, right? Which is true. You could reverse the logic, but it's not supposed to be that way, right? Of course, there's something, anybody doing physics, something called the elastic limit. Anybody? So like if you have an actual spring, if you pull it too hard, you could damage it. It would just kind of stay extended, not so? That's what's called the elastic limit. The point past which if you extend the spring, it will damage and no longer hooks or wouldn't apply. Right? Ends. Thank you. Right. Yeah. Even though I didn't take the physics that much in Form 5. There were certain things that clicked because it made sense. Right? I mean, I know V equal to IR, but me know what that is. Voltage, current, and resistance, something so. And then you had and so actually with that now you have an inverse relationship. But hold on. Let me do this one. Right? This one might be a little easier. Bottom 750. All right. So after this one, we'll have to do the inverse. We have to do an inverse one, which is the Jan 2025. Right? Yeah, that one for sure. Right. So people that my brethrens them at home, right? So you all could take a swing at this. Physics is complicated. Who's that? Noah? Yeah, physics could be complicated. I agree. Right. Everybody else decided one, so I guess I'll ask mine. All right, cool. Okay. All right. So the height h of an object is directly proportional, right? Oh crap! Completely wrong. I have the bounty on that side. I used to have here, but I kind of cleared it out. Yeah. Right. So directly proportional to the square root of its perimeter. So the height h is directly proportional to the square root of the perimeter. But what the first thing I want you to do is basically this thing here, right? The equation showing the relationship. So you would use h and the kind of open-ended infinity sign with the square root of the perimeter. And then it would, in the next line, you put h equal to some constant k by that same square root. Right? Try a tick. Do a tick. No? What happening? What are telling you? The height, which is what letter? H. So you start with H. H is, right, is directly proportional. What symbol we use for directly proportional? Correct. Right. That go to the square root of the perimeter. Right? You know a square root sign? Right? And the perimeter is P, right? Boom. That's it. Go ahead, frighten you. Right? So what I say now in the next line, you want to put the equation H is equal to some constant K multiplied by the same square root of P. That's all. Right. No! In part two, so instead of giving you a table, they give you the value of H for a value of P. And from that, you can find the value of K. All right, so do that first, and then we will talk about the next part. If you think you can do the next part, feel free. Sorry. Okay. what was that now? Chat, right. Oh yeah, I was supposed to send something to ChatGPT. Trying to enlist ChatGPT's help to see if we could predict what coming in this year. Okay, cool. All right. Subject is maths. Rihanna, what are the accounts? Well, the funny part, Rihanna, is actually the accounts for 6 hours today already. I did 10 to 12, 1 to 3, and then 4 to 6. 10 to 12 and 4 to 3 is the crash course. So that's not really, you wouldn't get the whole thing here on, what you call it? TikTok. You get like a minute preview. When you see, sorry? Yeah. Yeah. But only for like, it's a preview. So it's only get piece of it. Yeah. Yeah. So, so that way the cat. Yeah, it's called a subscription only live, right? So if they paid for the monthly subscription, which I didn't really set up. I mean, I have one set up, but nobody subscribing. But other than because I try too, because my wife normally logs on and say hi and check the chat and thing. And she's like, "Why I can't comment?" I'm like, "Oh, I put sub only chat and sub only live." She's like, "Why can't we get a minute?" I'm like, "Oh, that's just because it's the crash course now." So I'm trying to make sure that people don't like just extract all the information, you know. But I can't leave this one alone. Kill 9/2. Everything up. Okay. So when h is 5.4, when p is 1.44, square root of 1.44 is 1.2. Yeah? Anybody? And to solve for the value of k, you have to move the 1.2 to the next side. How is the 1.2 attached to the k? What operation? Multiplication. So how do we get to the next side? We divide. Correct. So we divide on both sides by 1.2. Right? And yeah, if you divide, you could actually move out the decimal point. And if you divide by 6, you get 9/4. Sorry, 9/2. Sorry, 9/2. If you have 4.5. Right, so 5.4 over 1.2, right? 5.4 is 54 divided by 10. 1.2 is 12 divided by 10. Right? So if I put 5.4 over that, it's like doing this. Right, 10. So what happens is these will cancel. This is C-sec. Yes, that's correct. The C-sec. Okay, we're again. So now we could state that H is equal to 4.5 or 9/2 by square root of P. So now, if P is 2.89, find the value of H. regular maths. Yeah, we good there? There we go. So h is equal to 4.5 by the square root of 2.89. Right? Square root 2. And it's 1.7. So 4 by 1.7 is 6.8. Half of 1.7 is 0.85. 6.8 plus 7.65? No? You have to square root it. Yeah. Yeah, 7.65. Right. What you could do, you could put a multiply sign between the 4.5 and the 2 the roots, yeah? Add maths, M's. Right, so M's. Here we're gonna, right? My assistant took over my add maths class because I had a lot of extra admin with Python. We don't stream her classes live, but 1 second. So I'm planning to hold on, sorry, it's not rendered, right? So add maths prep will start after the maths exam has passed, right? So everything in green is an add maths session. Right now, those are just proposed sessions, right? So what I'm proposing is I would actually kind of take back up my add maths class from there. So the answer is yes, but those mightn't be streamed for free, right? Those might be like crash course things you had to join, right? And I don't have any here because you have English B here, but if anybody's not doing English B, we could do AdMaths whole day, right? And of course, the AdMaths exam is Thursday, so I mean, English B and POB here kind of messing up machine, right? But if that's the case, we'll just do AdMaths in the evening here. So to answer your M's, yes, I'm planning to do some. It just might be until the 9th or 10th of May, all right? But if you check my channel, my YouTube channel, I have some AdMaths stuff there. You could always yeah, Caitlin. Yeah, sorry. You could always message me and let me know what topics you need help with. I'll see if I have anything I can send you. Okay. No problem. That's fine. Good. All the way down here, boy. What? Throttle me down.
fellas on Google Meet, just let me know if you guys good with that. Give me a quick genie chat, please, and thanks.
You're there? Only seen three of them now. Oh, Javier went. Okay, cool. No worries. Okay, cool. Thank you. All right. Okay, let me go again. All right. So, like I said, this one definitely have to do this one because it's the only one with inverse in this batch that I have here, right? So what I will do is I'll start you off by showing you how to approach items with inverse proportion. All right. All right, and this was Jan 2025, eh? All right. Oops. Okay, guys, this one has a difference. It says y is inversely proportional. What does inverse mean? It means it's flipped or the opposite or something, right? So when two things are directly proportional, if x and y are directly proportional, if y goes up, then x goes up as well, right? So this is direct. When things are inversely proportional, the inverse or opposite happens, right? Let's say A was inversely proportional to B. What that means is instead of just A proportional to, you'd have to put 1 over B, right? So what that means is as B goes up, right? So as B goes up, A goes down. And if B were to go down, A were to go up. That's what inverse means. Inverse means opposite, all right? So in this particular case here, I'll start you off with the statement, right? So if y is inversely proportional to x minus 2, we could start by saying y is proportional to, 1 over x minus 2. And that 1 over x minus 2 is actually the inverse of x minus 2, what we call the multiplicative inverse, all right? Right? Because you have different types of inverses, right? You have additive inverses, multiplicative inverses, right? And inverse undoes what was done before, right? For example, if I had x plus 2, right? If I put minus 2 here, this minus 2 is the inverse of plus 2 because it undoes the plus 2. Similarly, if I had x minus 2 and then I added 2, this plus 2 will be the inverse of minus 2 because it undoes or does the opposite of minus 2. So inverse simply means opposite or undoing, right? Similarly, if I have x multiplied by 3, and then to undo that, I divide it by 3. Division by 3 is the inverse of multiplication by 3. And division by 3 is the same as multiplying by 1 over 3. Because if you multiply 3 by 1 over 3, what happens? 3 will cancel with 3, leaving us with 1. Not 0, but 1. And if you think about it, if you put 3 over 1, multiply by 1 over 3. If you were to show the working, what's 3 by 1? That's 3. What's 1 by 3? 3. And is this not the same as 3 divided by 3? Right? So that's why it's called the multiplicative inverse, because when it will undo the multiplication. Right? Anyhow. Right. So here now, when you go to the next step, y is equal to k multiplied by 1 over x minus 2. Basically, what this would simplify to is y would be equal to k over x minus 2. Bunny in the wild. Okay, great. I'm glad to hear that. Bunny in the wild. Right. So now, what they want, so what they're saying here is that when x is equal to 11 when y is 9, they should have said it the next way, but y is equal to 9 when x is 11. So using the information circled in the green, you could plug that inside of here and solve for the value of k. So I want you to try that. All right. So if y is equal to k divided by x minus 2, and you have a value of 9 for y when k is equal to 11. Sorry, I can't seem to write a k today. I don't understand. Oh my gorm. Okay, whatever. Leave it alone. Right? So 11 was the x, 9 was the y. So we plug them inside of the equation there, and we're going to solve for the value of k. That's not what I want. Well, that's interesting. Oh, okay. You all right, Bob, then? Okay, so what's 11 minus 2, Khalifa? 9. So if we have k divided by 9 is equal to 9, how do we then solve for the value of k? Correct, we'd multiply by 9 on both sides of the equation. What's 9 by 9? 81. So 81 is the value of k. So now we could say that y is equal to 81 over x minus 2. So now they wanted to find the value of y when x is 29. You're going to sub 29 inside of here and solve for y. Oh, just put it. So is it inversely proportional? Wouldn't it be 1 over k? M's. No, remember the item is inversely proportional to x minus 2, right? So it's some constant multiplied, So when it's inversely proportional, the constant is being divided by that x minus 2, right? But I understand why you would think it's 1 over k, because that's an inverse, right? But it's inversely proportional to x minus 2, right? Video light, mount battery, no. Rig the light, no. Well, control wheels, no. That. 120, no thanks. Hold on. Crab shaped clam. 20, I could do. 16, I could do. Rosette. Very much, guys. Right. All right, so Bunny saying 3, Kaelan saying 3. All right, let me take a look and see what's going on there. Right, so if we substitute 27 there, we'll have 81 over 29 minus 2. 29 minus 2 is 27, and 81 divided by 27 will give us 3. All right, cool. Lovely. Okay, Khalifa, we okay with that? Ziam, we okay with that? Ladies, on this side, we okay with that? 3? All right, fellas on Google Meet, you know the drill. If you're good with that, give me a quick genie chat, please, and thanks. All right, Donovan. Yeah, okay, good. Hey, Javi, you're back on the inside. Nice. Good, Liam, no. Liam gone now? Javi, you come back and Liam gone? Yeah. Okay, cool. But and pongs or kilograms? Ounces. All right, cool. All they have about them new Olympic Games they're bringing out for special people. Another one. It's that one where you could play table tennis while on the toilet. Yeah, it's called pooping pong. Yeah, but it's our next one where you could ride a tortoise and jump over little things. It's called turtles. Turtles. It's our next one where they have this round thing to throw, but they have to talk to somebody while throwing it. It's called discuss. Yeah. For what? What are you saying? All right. Global, what you want to do? Put that air conditioner by the earth? All right, folks, we're going again. Binary operation. Right. So binary operations is something a lot of Form 3s and Form 4s come in and is don't know what to do, right? Basically, a binary operation, they take a bunch of things, like a bunch of like this, and what they do is they put a symbol to it, right? They just assign a symbol. It have no rhyme or reason or rule. They just decide, hey, what? We want this symbol to mean doing this with A and B, all right? So all you're doing is just substituting 1 for A and 2 for B. So I want you to plug 1 and 2 inside of here and give me an answer. All right, now I only have one of these, right? I then go back past 2015 to get more. So I should have, but I didn't. All right. Oh. It's at our next one in these sports where it was in Trinidad. Sorry, it was a long stick with a pointy end. You had to get from one point in the country to the next by going on a train. They call it traveling javelin. And the next one, you have to put a very small glass with alcohol on a very high point using a very narrow ladder. It's called the shot put. And it had the next one where you had this long stick where you had to put in a safe as the pole vault. And it had one where you had to smoke weed before and then jump, the high jump. Huh? No, I'm talking rubbish, right? He was taking me serious. Yes. Right. And they had a similar one where you had to smoke weed and then dive. That's the high dive. You believe everything I say? Yeah, I read I thought of some jump over some turtles.
No, what is it?
That might be suspect, right? What was the other one I just thought of just now? Oh, you had to attach. You have these two vertical poles, and you had to run wire back and forth until they make a wall called fencing. And I had a very strange one for swimming. They had to catch one of those insects with pretty wings that fly and do this did. Butterfly stroke. And they had one where you had them rappers, like the rappers or like how they have extempo in carnival, right? And put them to swim, freestyle. Hmm. And the next one where you would rub somebody back as a backstroke. All right, okay, so what do we get? So 1 star 2 is equal to the square root of 1 plus 4 by 2. What's 4 by 2? Nope. 4 plus 2 is 6. 4 by 2 is 8. 1 plus 8 is 9. Square root of 9 is 3. Right. Now, this next piece they're asking you for here, whether determine whether the operation denoted by star is commutative. What does commutative mean? What is the same thing? Correct, right? So was 1 plus 2? 3. Was 2 plus 1? 3. So addition is commutative. What is 2 by 3? 6. Right? And what is 3 by 2? Also 6. So multiplication is also commutative, right? So they're asking now, if you were to switch these numbers, would you get the same answer? That's what commutative means. It means if you change the sequence of appearance, would you get the same answer? So let's check it out. So if you do 2 star 1, that means you do 2 plus 4 by 1. What's 4 by 1? 4. And what's 2 plus 4? 6. And the square root of 6 is 2.4494 something, 8743, 89743. Square root of 6, 2.4494897743. Yeah, 449489744. So long story short, 2.45, right? The three significant figures, right? Would they equal? Are they equal? No. So since they're not equal, is the operation commutative? No. And it's not commutative because 1 star 2 is not equal to 2 star 1. Lovely. Okay, cool. Right, so that's all the binary operations I have here right now. In 10 years are possible questions. As I have it once. The syllabus is too big to effectively test everything all the time. Most syllabuses are. All right. We did proportions, we did simultaneous equations. That one to do. Yeah. Oh, yeah, that's right. Where it was? Where we did binary operations? Right. Binary operations. Oh. Yeah, bunny. Okay, later. Thanks for the love. Life saying. Oh Lord. I didn't put that on mute. Oh. All right. Hey NS, good night. How you doing? What does NS stand for night, sir? All right, cool. All right, guys. So we have one simultaneous grid. So after this, we'll probably call it a night. Next week, I will try to compile all them quadratic factorization business for you all. Oh, it's Noah. Oh, Noah, sir. All right, cool. Sick right now. Oh gosh, hard luck, boy. Well, at least you're sick now, not during the exams. So get better fast. Next week is just one day, Wednesday. The week after, Monday, Wednesday, usual. The week after that, yeah, early May. Yeah, after from the 6th of May. So 6, 7, and 8. Tuesday, Wednesday, Thursday, yeah. So Tuesday is just in the evening. 4 to 6 and half 6 to half 8. And Wednesday, Thursday, so is fully 10 from 10 in the morning until half 8 in the evening. No, Monday, Tuesday is POA. So Monday is POA. And then Monday we be in POA. POA is, so POA exam is Tuesday. Correct. So between Tuesday evening and all day Wednesday, all day Thursday, we'll get 10 sessions in. Yeah, so next week and the week after, kind of normal. Cool. All right, so when they give you equations like this, right? Anytime you have one of the items with a coefficient of 1, right, that's where you could use substitution, right? Although you could also use elimination. I kind of prefer that one, right? But let's use substitution for now. So from this equation here, if you wanted to make y the subject, you'd have to kind of move the 2x, right? And you do so via subtraction. So y would be equal to 3 minus 2x. And then you would sub that inside here. You'd replace y with the expression 3 minus 2x. So equation 2 would now become 5x minus 2 multiplied by y, which we are substituting 3 minus 2x in place of, as equal to 12. Right, so now when we expand using distributive law, minus 2 by 3 is minus 6. Minus 2 by minus 2x is plus 4x. Because a minus by a minus is a plus. If we rearrange, we could put the algebra together. 5x plus 4x is 9x. 9x minus 6 is equal to 12. Now, if 9x minus 6 is 12, how do we move the 6? We have to add it on both sides because it's being subtracted here. So we need the opposite operation to move it over. So, sorry. It's not 8 is 6, sorry. 12 plus 6 is 18. And to solve for x now, how is the 9 attached? What operation? Multiplication. So to remove it, we need to use the opposite operation, which is division. And of course, whatever happens on one side of an equation must happen on the other side. So x would be equal to 2. Now, we're going to use that value of x to solve for y. So y is equal to 3 minus 2 by x, which we just solve as 2. 2 by 2 is 4, and 3 minus 4 is minus 1. The value of x is 2, the value of y is minus 1. Right? You don't have to do that table thing. That's just something they taught me to do, and I kind of like to do it, but you don't have to. You can clearly see a value of x here and a value of y there. That's perfectly fine. Right? Now, if instead of doing that, you wanted to use elimination, let's talk about that real quick. To use elimination, the coefficients, you have to have the coefficients of one of the algebraic variables has to be the same between the equations. Right now, for the x's, you have a 2 and a 5, and for the y's, you have a 1 and a 2. But we could either modify the x's or the y's. The easier one is the y's. How do we modify it? By scaling up the equation. What does that mean? We multiply it by a number that would change this number to that number, right? By what number would you multiply 1 to get 2? By 2. So you have to multiply the whole equation by 2. You can't just scale up one item, you have to scale up the whole equation. So we're going to multiply this whole equation by 2. So 2 by 2x will give us 4x. 2 by y will give us 2y, and 2 by 3 is 6. All right, bringing back the second equation just below it here. Now, we have to either add the equations together or subtract one from the other to eliminate that variable that's the same coefficient. Now, how do we know? We subtract if we have the same sign. Do we have the same sign in front of the 2's? No. So we can't subtract. If we can't subtract, what's left available to us? Add. Correct. Add. So 4x plus 5x is 9x. 2y plus minus 2y. So if you look at it like this, so 2y plus minus 2y would simplify just to 2y minus 2y. What's 2y minus 2y? 0. 2 minus 2 is 0. 2 plus 2 is 4. All right, so 9x plus 0 and 6 plus 12 is 18. So if 9x is equal to 18, to solve for x, what would you do? You divide by 9 on both sides of the equation. X would therefore be equal to 2. Right? Now, let's say that you wanted to eliminate, instead of eliminating y's and solving for x, let's say you wanted to eliminate x and solve for y. Now, you have a 2 here and a 5 here. Now, what you can do, the easiest thing to do is to multiply each equation by the opposite coefficient. What I mean, this equation, it multiply by 5. They multiply this one by 5, and this equation, it multiply by 2. It multiply by the coefficient of the variable in the other equation. Right. So 5 by 2x will give us 10x. 5 by y is just 5y. 5 by 3 is 15. Right. And in the second equation, 2 by 5 is 10. 2 by minus 2 is minus 4. 2 by 12 is 24. Right. Now we have to add or subtract the equations together to eliminate the variables. So again, we subtract if the signs are the same. For the x coefficients, are the signs the same? They're both positive. There's no sign in front of them, which means they're both positive, right? So yes, we're going to subtract. 10 minus 10 is 0. Here you have 5y minus 4y. So if you have 5y minus 4y, what does that become? When you minus a minus, it becomes a plus. 5y plus 4y is therefore equal to 9y. And don't forget 15 minus 24 to the back here. 15 minus 24 is minus 9. So if 9y is equal to minus 9, to solve for y, how do we remove the 9? How is it attached? Multiplication. How do you remove something attached by multiplication? By division. So we'll divide by 9 on both sides of the equation, and minus 9 divided by positive 9 is minus 1, which are the same values we got across here. 2 for x and minus 1 for y. All right. Okay. Folks, we're going to call it a day there. Now, like I was saying, next week we only have 1 day of class. Huh? Oh, yeah, sure. Oh. Yeah, so guys, we have a long weekend. This weekend coming here, we have Fridays, Good Friday. Next week, Mondays, Easter Mondays, a holiday, so no class on that day, right? So we will pick back up on Wednesday, where we will start we're still in algebra, but we'll start quadratics, factorization and solution of quadratics, and maybe computing the square and some of those interesting looking questions where you had shapes and rectangles and seed beds to worry about, right? So that'll be about 3 sessions, and then when we'll put a pin in it there, and then we'll pick back up on the 6th, the evening of the 6th of May. All right. So I don't know who left in Google Meet there, boy. All right, DeAndre Donovan, that's about it, right? So if you guys have any questions, please feel free to WhatsApp me. Other than that, have a good evening. Enjoy the Easter, and I'll see you guys next week. Bye. All right. YouTube. YouTube. Oh, you going? All right, cool. All right, later. So how was he saying?